everyone. Welcome to another Cosmos DB Design Patterns. I'm Mark, and got Jasmine here with us again. So, hey, Jasmine.
Oh, hi, how's it going?
I'm doing great. I want to talk about a pattern that is kind of a strange pattern in a way. This is something that we get asked from customers all the time, which is, and they ask for it in a couple of different ways. They may be like longtime SQL users, and they're like, you know what, I want to migrate my app from like SQL over to Cosmos, and I need an auto increment function or something. Like, do you guys have auto increment? And the answer is no, we don't do auto increment, because that if you do auto increment, you have to put a lock on your data. And we don't do pessimistic locking. That's a pessimistic lock you have to put on there. We do optimistic locking. So we take a snapshot and then we check to see if you've changed it, and then we fail it if it has changed. So we don't do that. Another thing we've seen customers ask is, I want to do, well, they basically say, I want to do locking, kind of like they do in SQL. Like, I've got a long running transaction, some other thing. I want to put locks on stuff. Can you do that? And again, just the same as with the auto increment, the answer is no, we don't do that. Like, and we will never build a way to do that. And of course, people are kind of crestfallen over that because they want that functionality. But what I tell them is, look, we don't provide that in the service, but you can actually use Cosmos to build your own lock. And so that's what this pattern is here, is how to build a globally distributed lock. And the way this kind of works is it uses two things in Cosmos that are part of the service. One is it uses our optimistic concurrency control. So I talked about how we do locking. We don't do locking, but we use this thing called optimistic concurrency control, which basically we implement using an E tag. So when you write something to the database, we write an E tag in there. It's one of the system properties. And then when you are using optimistic concurrency control, you check the E tag if you do an update. And if it's changed, we fail it back. We throw an exception back to the user in there. The other thing we have that it uses in here is TTL. So you can set a TTL on a document within Cosmos DB. You set it for the container, and then you set it for a document within there. And then we will expire that document when that TTL hits. There's one other feature that is used when doing this, which is consistency. So we replicate data, right? So Cosmos is distributed. We can distribute that data into many regions. In fact, every region in Azure, if you really want. And you manage the replication and RPO of that data using consistency and these consistency models. And to do a distributed lock, you need to implement, and of course, if you're going to distribute that data, you need to use consistency. And what you're going to do is, for this scenario, you would use strong consistency, because you can never have a dirty read in a scenario where you were trying to enforce a global lock on some resource in a distributed environment. So that's the other piece as well. That's another feature of Cosmos that allows you to go and build this thing. So this whole thing kind of walks you through the scenario in here. And what we did is we implemented this global lock for kind of like a fictitious lock. So you just give it a name, and then we have three different processes within here that will try to gather or grab that lock and take a lease on it over a period of time. So this whole thing will walk through kind of how we implement it, and then this will show kind of how the whole thing works. So we'll have three different processes. We have a pink, a cyan, which is kind of like a light blue, I guess, and then blue in here. And each of those are going to try to acquire a lock over some period of time over the course of this whole thing that I'm going to show you, and then we are going to see how that works in there. So let me get to the app, and I'm going to go here. And here's my little local version of this thing. So let's go ahead and we're going to do .NET. Whoops, not .NET Interactive. We're going to do .NET Run. And we'll give this just a second. It's going to build. Okay, so first thing is we're going to enter the name of the lock. So I'm just going to call this Mark Test Lock in here. And we want to enter a TTL and the duration for the seconds that lock can expire. So we'll just say 5 seconds in here. So now this is going to warm up. And now you can see this thing is going to run. And each of these different processes over some period of time is going to try and acquire that lock over, I think this thing runs for about 30 seconds. And so what it'll do is it will keep trying, and it'll either be successful or it's going to fail over that period of time. So what happens is one of those processes acquires a lock, it does some fake work in there, and then it releases the lock. Meanwhile, the other processes are trying to acquire that lock because they want to acquire the lock so they can do some work as well. And here you can see, all right, it's all done. So if I walk through, we'll go scroll back up here and you can say, we can see, okay, going to warm up these threads. I got 3 of them says hello, and then pink sees the lock and has token 1, and it's going to acquire a release. And then here you can see it acquires a release, and you can see success, and then it's going to hold it for some period of time. So here it's 1102 milliseconds. And then during that time, you can see these other processes are going to try and acquire the lock, and you can see it's going to fail because the pink has already got it. And then here, blue tries and it fails. And then pink is like, okay, I'm all done. I'm going to release it. And now blue is going to be like, oh, I'm going to try and get it. And it wasn't ready yet, but cyan sees it and it says, okay, I'm going to get it. So success there. Now, one thing I want to call out, remember before I was talking about people wanted to use or wanted an auto increment feature for Cosmos. The way this lock works is it uses a concept called a fencing token. And a fencing token is basically a monotonically increasing integer. In this case, it's essentially an auto increment number. And if you look at here, when I first grabbed the lock for this thing, it had a token of 1 within here, right? And then it did some work. The next time it gets accepted or success, you can see the token is now 2. And that is fundamentally how this thing works. Within here is it uses this fencing token. Each of these processes, if they want to acquire that lock, need to come in with the right fencing token, which means that it needs to increment in order to capture the lock if they want to get it. And so you can see it's 2 in here, and then the next successful one, the token is 3, and so on. And it just keeps going and going and going until I guess that you run out of numbers in the integer case. So that's kind of it. So that is distributed lock within here. And again, this is all available within our Cosmos DB design patterns repository. So go and check that out, and you can go and play with this and implement your own distributed lock using Cosmos DB. What do you think, Jasmine? Do you think that's cool?
Yeah, that was really cool. I actually learned something new today. I learned about fencing tokens. So I'm actually curious to try it out myself.
It's a lot of fun. Lots of cool stuff you can do with Cosmos. Even if we don't implement the feature itself, you can go and you can build it and have fun doing it as well. So anyway, we hope you enjoyed our Cosmos DB design pattern for distributed lock, and we hope to see you on another one here sometime soon.